Okay, today we are going over 2.5 absolute value functions and graphs. So let's take a look at some absolute value functions and graphs. We're starting off with the equation of y equals the absolute value of x. And we know that when we have the absolute value of something, then we have positive values. Okay, so what that's actually doing is you can plug in positive and negative values for your x, but what's going to happen is the y's will all be positive. So if we're going to graph y equals the absolute value of x, we can plug in 0 and we get 0. We can plug in 1 and we'll get 1. I can plug in -1 and I'll get 1. Plug in 2, I get 2. -2, I also get 2. So if we look here, the absolute value of something is actually going to be drawing a V-shaped graph here. And that's because it's making everything positive here. So this is our parent graph, which is the simplest version of an equation. And this is the absolute value of x. Okay, so now we're going to look at when we have f of x, which is the same as writing y, when y is equal to the absolute value of mx plus b plus c. So in order to find the vertex of this, we first need to know that m cannot equal 0, because if m is 0, then we'd have no more x here, and then it won't be an absolute value function. So to find the vertex, we know the vertex is a point where the function reaches the max or the min. So in this case, this is our vertex, which is at 0, 0, and this point is our vertex, and it is the minimum of this graph because it's the lowest point on this graph. Okay, so to find the vertex of other graphs, we're going to use this equation here. The vertex is equal to -b over m comma c. So we're going to plug in values for this and find what the vertex is equal to. So let's try some problems. All right, here we go. We got y is equal to the absolute value of 3x plus 12. And if you would like, we can put our equation here right underneath as a guideline, plus c. And notice for this one, there's no plus c, so you could just put plus 0 so that you know that the value of c is 0. So we're going to evaluate the equation for several values of x, and we're going to start with -b over m. And that's because we know that the vertex, the equation to find the vertex is -b over m, comma, c, which we learned in the previous slide. All right, so plugging those in, our b here, so our m is 3, our b is 12, and our c is 0. So -b over m will therefore be a -12 over 3, which is a -4. So the vertex is going to be -4, 0, because your c is 0. So we have -4, 0 right here, -4, 0, which is my vertex. And now this is actually going to help with my slope. So we could do this a couple ways now. After I find this one point, I can use the slope by rising 3. Looks like I went up by 2's here. So here's where the 3 is. Okay, so I can rise 3, and then I can run 1, and you need to run 1 in both directions here. I'm going up by 2, so this is a -5, this is a -3, and so on. Okay, and you can keep going the same way. So you can rise 3 and run 1, rise 3 and run 1. Okay? And you can see that this is the point -3, 3. This is the point -5, 3. And what you can actually do to check this is, sorry, my graphs are pretty terrible, but these should look like V shapes. Anyways, so you can actually plug in these points like -3 for your x, and you should come out with your y value to be a 3. So let's try that and see if it works. So if I plug in my x to be -3, let's see what we get. Okay, so we have 3 times -3 plus 12. So that's going to give me 3 times negative 3, negative 9 plus 12, and 12 minus 9 is 3, and the absolute value of 3 is 3. And look what we got. Our y value to be a 3. So there we go. Awesome. Moving on. Okay, let's try one more like this. We're going to do this one. So notice here we got this negative in front. So if there's a negative in front, that means that the absolute value graph is going to face down. So it's going to be an upside down V, like that. Okay? So we're still going to use negative b over m comma c here. So let's see. We have our negative b. So we have m is 1. M is still the coefficient in front of x, the one that's inside the absolute value. Your b, so mx plus b, your b is 1, and your c is negative 2. Okay, so I'm just going to cross that out there. Okay, so we have negative b over m, so we got negative 1 over 1 comma negative 2. So that's going to be a negative 1, negative 2, and that is our vertex. We'll graph that, negative 1, negative 2, negative 1, negative 2 down here. Negative 1, negative 2, I'm going to label that as my vertex. And now my slope is a 1, so I'm now going to go down because of this negative guy here. So I'm going to go down 1 and over 1 in both directions. Down 1 and over 1, both directions. Okay? And if we want, we can actually plug in an x value. So if I plug in my x to be 0 here, I should come out with a negative 3, because here's the point 0, negative 3, right? So let's see what happens there. I get y is equal to negative absolute value of 0 plus 1 minus 2. Negative absolute value of 1. So this is absolute value of 1 times a negative 1 is negative 1 minus 2 is a negative 3. So I get the point 0, negative 3, which is what we had before here using the slope. Okay, sorry for my crooked lines, but that should be, those are straight lines, upside down, V. Awesome. Moving on. Writing two linear equations. So this is another way to do this. It does take a little bit longer, but it's a good process to go over and understand why, when we have absolute value functions, why we get that V shape. So here's why. Here's what happens. We're going to first isolate the absolute value, this guy here. Okay, so we'll do that. We're going to isolate it by taking the equation and bringing that 5 over. So I'm going to subtract 5 from both sides here, and I'm going to get y minus 5 is equal to the absolute value of x minus 3. All right, so now what we're going to do is we're going to use the definition of absolute value, meaning we're going to write one that's going to be positive and one that's going to be negative. Okay, so when we actually do that, we're saying that we're going to say what values to plug in. So when x minus 3 is greater than or equal to 0, I can actually solve that. So we're going to have two different things here. So solving this here, adding 3, I'm going to get x is greater than or equal to 3. So I'm only going to plug in values that are greater than or equal to 3 for this equation. And I'm going to break this up. Okay, I'm going to break this up here where one of the absolute value will be positive, meaning this is positive, right? Greater than or equal to 0 means positive. So meaning y minus 5 equals x minus 3. And less than 0 means negative. So I'm actually going to take this and negate whatever is in the absolute value here. So I'm going to only plug in values that are greater than or equal to 3 here, which I can actually take this equation and make it into a form that I know a little bit better, y equals mx plus b, which is going to make things easier to graph. So adding 5 here, I get y is equal to x and then plus 2. 5 minus 3 is 2. So I'm going to graph this equation only for these values. This is your domain for this. That's a 2, by the way. 2. Yep, there we go. Okay, and then adding 3 here, this will be the domain. I'm only going to plug in values that x is less than 3. So using this here, I'm going to distribute in your negative, and I'm going to get y minus 5 is equal to negative x plus 3. Getting this 5 over, I get y is equal to, that will cancel, and I get a negative x plus 8. So I'm going to graph this equation for these x values. Oops. All right, moving on. So here's the work for that. There it is. Okay. So now I'm only going to plug in values 3 and bigger for this equation. So I can make a little table here. X, and then I'll see what I get for my y's. Plugging in 3. 3 plus 2 is 5. Okay, I can also plug in 4. 4 plus 2 is 6. Plug in 5. 5 plus 2 is 7. Okay. Now I can plug in values here as well. But for this one, I'm going to plug in values that are less than 3. But if you notice, if I actually plug in 3, I should get the same point here because that's actually going to be their intersection. So I have a negative 3 plus 8, that's a 5. Okay, now plugging in values that are less than 3. So like 2, if I plug in 2, negative 2 plus 8, or 8 minus 2 is 6. Plugging in a 1, negative 1 plus 8, 8 minus 1 is 7. And so on. So this point, the 3, 5 is actually where they intersect. So 3, 5 is where they intersect. And if we did it the other way that we did before in mx plus b plus c here, and we did negative b over m comma c, look what happens. We get a negative. Negative 3 is a 3 over m is a 1 comma c. And we get our vertex to be 3, 5, which these lines are crossing at 3, 5. The same as what we got for the vertex. So here's 3, and then here's 5. Okay, that's 3, 5. 3, 5. And now we can plot the other points. So we had 4, 6. Here's 4, 6. We had 5, 7, 5, 7 right here. Okay, and then this line, it would normally continue, but we're only going to use the points that are going to be greater than or equal to 3. So going this way. And this one, we're only using the points that are less than 3, right, for this one here. So I have 3, 5. That's good. We have 2, 6. We have 1, 7. 1, 7. 1, 7 right here. Right here, sorry. Okay, 1, 7. There it is. And these points, we're going to stop at the x to be a 3 and then continue on. And there it is. That's how we graph the absolute value graph, by splitting it up into 2 linear equations. Okay, so last one here, just to write down the vertex and how this would affect it. Wrapping it up, we'll use negative b over m comma c is our main thing for today. This is our mx plus b plus c. So I'll just write down the vertex for this one, and then you can try this equation and graphing it on your own. So you have a negative 4 over m, your m is 3 over 2, comma, negative 3 for your c. So we know that when we are dividing by a fraction, we multiply by the reciprocal, which is 2 over 3 now. Okay, so this is going to give us a negative 8 over 3, which is the same as negative 2 and 2/3, right? 3 goes into 8 2 times with 2 left over. So your vertex for this is negative 2 and 2/3, comma, negative 3. Here's your vertex. Here is your slope. So from this point, it'll be facing up, and you'll rise 3 and you'll run 2. And that is wrapping up our lesson for today. 2.5 absolute value functions and graphs. Thanks for listening. Bye-bye.